I'm talking to you though. You're the stats guy.
Yeah, we're trying to.
You're the stats guy, and we're the homies.
What is up, homies? We are back today, and I am wearing my Isotopes shirt. If you don't know who the Isotopes are, then you are a casual baseball fan. No, the Isotopes are the only thing that New Mexico has by way of a professional sports team. So everybody in New Mexico is a big Topes fan. But anyways, probably guessed it. We're talking baseball. The World Series just happened, and boy, did it happen to the Yankees. I wanted to talk about it because I thought it would be fun to go through each game and try to apply some prediction and some like predicted outcomes and things like that. And what I found was really interesting. So on TikTok and while the games were happening, I didn't actually watch the games, but I did see a lot of the Yankees just messing up a whole bunch. Stanton couldn't run to save his life. Yeah, they were all just pretty much terrible on the Yankees. And so I thought, I wonder if they blew it. Like, I wonder if the Dodgers outplayed them or if they just blew it. It was theirs to lose. And the latter actually ends up being correct. But we'll go through it. We're going to go through it step by step. So first, I have to talk about the methods I used. So in order to ascertain the probabilities for each game, I use a logistic regression model that included hits, walks, stolen bases, and then the opposition's numbers for all of those. And it integrates home field advantage. And from there, you can do some calculations and get out the probabilities. Yeah, I'll also report the odds change because odds and probabilities are linked, and so if you have one, you can have the other as well. And then I also, just for fun, kind of tried to predict the run differential on the same model, but with the continuous outcome. So, yeah. Okay, so let's go through the results. First of all, I used a sample of like more than 2,000 games. So the results are definitely going to be significant pretty much no matter what you do. There is an inextricable link between sample size, significance level, and effect size. So even if you have a small effect size, like you can see, some like the smallest effect size is negative 0.16 runs. It's not a good portion of a run, but it's really highly significant in both models because so many data points. So that's pretty much what you're seeing there. So I wouldn't pay too much attention to the significance. In fact, I didn't even report the p-values or anything. I just reported that they're all really highly significant, well below 0.001. And the results themselves are the most interesting. So if we go down the list, so hits and opponent hits were the most impactful. So if you got a hit on the opposing team, your odds to win the game improved by 54%. And if the opponent got a hit, your odds decreased by 35%. Interesting that for the odds model, it seemed to be a little bit better for the home team. Like a home team hit seemed to have a bigger impact. Whereas with the runs model, they were like almost identical. Like if you got a hit, you had a 0.7 expected runs. And if you gave up a hit, it was minus 0.7 expected runs in terms of differential. We can go through walks. Pretty much the same odds, plus 17, minus 20, and then plus 3.34 and minus 0.35. So again, really, really close on the linear regression model. And then stolen bases, plus 20%, minus 20%, and then plus 0.34, minus 0.35. So one thing I'll say about these results is that, especially for the linear regression model, it looks like home field doesn't have an interactionary effect where if you're at home, you might expect that a hit means more, like it juices up the crowd or it gets the home team going, and that doesn't seem to really be the case. And in fact, baseball has one of the weakest home field advantages. I'm not sure why that is. Maybe just the massive number of games that they play. It kind of loses its luster, but who knows? Yeah, so I think we've gone through all the results. So let's go game by game because it was a very strange World Series at its face. So game one, Dodgers had 7 hits, 2 walks, no stolen bases. Yankees, 10 hits, 4 walks, 4 stolen bases. If you just took those 6 numbers as a box score and someone said $100 if you can guess who won this game based on those numbers, hands down, you would say Yankees won that game. Easy. In fact, the model predicted a Dodgers loss, and they only had a 10% probability to win the game. And what did they do? They won it by 3 runs. The model predicted a negative 3.3 differential. That is to say that the Yankees would win by 3 runs, and the Dodgers won by 3 runs. This is a crazy game. You should not lose this game if you're the Yankees. There's just no way. So now I'm thinking, does my model suck? Maybe. Dodgers at home, game 2, again. Dodgers had 8 hits, 1 walk, 1 stolen base. Yankees, 4 hits, 2 walks, no stolen bases. So in this case, you're like, okay, this one's pretty obvious. Again, Dodgers win that, right? Yep. And indeed, they had an 88% probability to win, plus 2.8 runs. And the models predicted a Dodgers win and plus 2 runs. So super, super close. I'd say that's a massive success for the model. Now we switch to the Yankees at home. So now all the predictions are going to be in terms of the Yankees. So Yankees at home, both teams had 5 hits. Both teams have 6 walks. The Dodgers had 1 stolen base. Yankees had none. So again, if you're only given these 6 numbers, you might think, ooh, that stolen base might put you over the edge. But it's pretty much a toss-up, right? Coin flip. And indeed, the model predicted a Yankees loss because of that stolen base and a 45% win probability with negative 0.03 runs predicted against, which is super small number you'll see, less than a run. So yeah, neither model was confident about this prediction, but it was correct. The Yankees did in fact lose by 2 runs. So not really close on the runs, but close on the outcome, or correct on the outcome. Okay, we'll go to game 4. Yankees at home again. The Yankees had 9 hits, 6 walks, 5 stolen bases. Wow, great game. Dodgers, 6 hits, 3 walks, 1 stolen base. Okay, this one's easy. In fact, this was the highest probability that was predicted in the whole series. Yankees win with a 94% win probability, plus 3.9 runs. It's really hard to linearly predict because not a lot of games are won by 4 or more runs. So once you extrapolate to data that a whole lot of it does not exist, the numbers start getting a little bit wonky. But suffice to say, the models predicted a sure win by a bunch of runs, and that's what they did. They won by 7 runs, bunch of runs. So pretty normal game. Then you get game 5, Yankees at home again. Yankees had 8 hits, 9 walks, no stolen bases. Dodgers, 7 hits, 7 walks, 0 stolen bases. Okay. Let's think about what these numbers mean. The Yankees, just based on these 6 numbers again, had at least 3 extra bases in this game. At least 3 extra bases. And if that hit was a home run, that's a bunch more extra bases. So you're expecting at least one of those had to get through for a run, right? And so the models predict they win with a 67% win probability. That's pretty high. And plus 1.4 runs. Again, one of those guys on base gets through for a run. But what happens? They lose by a run. Okay. So twice in this series, the Yankees beat the odds the wrong way. They beat the odds by losing games where they should have won. One of them was this 67% win probability, and the other was game 1, where the Dodgers only had a 10% probability to win that game, based on the stats that occurred in the game. I'm not even talking about something that you could pre-specify before the game happens. I'm talking about as the game unfolded, the stats that came out, you should have won the game. How the game went, you should have won it, and they didn't. So the question is, what happened? Here you go. They lost a game with a 67% probability to win and with a 90% probability to win. So in game 1, Yankees 10 hits, Dodgers 7. Yankees 4 stolen bases, Dodgers 0. You can't lose this game. You can't. You picked up so many more bags than the other team. But what happened? Well, 8 out of 10 of those Yankees hits were singles. 1 home run and a double. The only 2 hits that weren't singles. Meanwhile, 5 out of 7 Dodgers hits were for extra bases. So they hit for power. The Yankees hit for singles. And it did not get the job done. This was kind of the easiest one to see. Like, well, that's obviously what happened. Now let's look at game 5. This was the craziest one to me. If you look at any statistic that came out of the box score of that game, you'd be like, how did the Dodgers pull this one off? Yankees, 19 total bases. Dodgers only had 8. Dodgers only earned 8 total bases. Yankees had 3 home runs, and the Dodgers didn't have a single home run. That's 3 guaranteed runs to Dodgers none. The Yankees were better in OPS and on-base percentage and batting average. That's the triple slash. I mean, they were better in pretty much any category, offensive category you could possibly put them in. So what happened in Game 5? The Yankees had 3 errors. Dodgers didn't have any. It's the highest level of baseball. It's the World Series. You don't really expect errors in this game. Dodgers had 0. Yankees had 3. Craziest part is the base runners. Given all the statistics that you've seen from this game so far, wouldn't you guess that the Yankees had way more base runners? Yankees had 18. Dodgers had 15. Again, it was so close because they got unearned base runners. They got guys on base via errors. And, can't happen. Yankees end up giving up 5 unearned runs. That is how you turn a 2/3 probability to win into a loss, by giving up 5 unearned runs. Think about this. Even if they had only given up 4 unearned runs, which would be unheard of and absurd to give up 4 unearned runs in a game, in a World Series game, even if they had only done that, it would have gone to extra innings and they could have won it. Like, the fact that they gave up 5 and lost by a run is absolutely ridiculous. So, and then this last one, the Yankees used 5 pitchers, Dodgers used 8. Garrett Cole didn't give up. He pitched 6 innings. He didn't give up any earned runs. But again, all the errors and what happens. And the Dodgers were willing to go into their bullpen early, and their bullpen saved them. It was like good management. So what this tells me is that Yankees, roster-wise, skill-wise, probably on par with the Dodgers. They got there for a reason. Meanwhile, their management has to be terrible, right? I mean, I should probably, before I'm saying all this, go back and watch the games and see how they were managed and if any blunders occurred. But I can't imagine that a team that puts up 3 errors and 5 unearned runs is well managed. Dodgers just put on a masterclass of how to do a lot with a little. Meanwhile, the Yankees had all the right stuff to get the job done and couldn't. Incredible. A statistical outlier of a World Series if there ever was one, but fun to go through. So that's all I have. We will see you next week.